Hi everyone and welcome back to Matthew Wister. Today we're going to be talking about voltaic cells and chemistry. To start off, I'm going to tell you some things that you typically associate with voltaic cells. Voltaic cells involve spontaneous redox reactions, which means that there's no direct outside source in order for the reaction to happen. Voltaic cells are also considered galvanic cells, and in these cells they convert chemical energy into electrical energy. Electrons in the more reactive cell transfer to the less reactive cell, so it's from an anode to a cathode, and I'm going to explain what those two terms mean. A salt bridge is present, allowing the flow of ions to balance the reactions, and voltaic cells contain two cells or solutions. Okay, so here we have a voltaic cell. We have a voltmeter, we have a salt bridge, we have an anode, a cathode, and we have our two different solutions. Now, there are some labels that I'm going to point out, such as Zn is one of our metals. And right next to Zn, it says it's an anode. Then on the right, we see Cu, and it's a cathode. Now, in these little bubbles that we see here, it's telling us what's happening inside the metal. And right now what we're seeing is that there are electrons, or these negative symbols, exiting the cell. So that means it's losing electrons. And if we're losing electrons, that means that Zn is oxidizing. And if Zn is oxidizing, it's becoming smaller. And also, if it's losing electrons, it's gaining an excess of positivity. So it becomes a cation, or Zn becomes a cation. So we can see that here in the little equation that's here. The oxidation half reaction. We see that we're adding electrons, however, it's in the product side. And whenever you're adding electrons on the product side, it means that you're losing electrons. And we can also see that Zn is becoming 2+. And we can see that in the little bubble again. We see these 2+ ions. Now, we can see the flow of electrons moving from the anode through the voltmeter and to the cathode. Now, the cathode is the one gaining electrons. And if it's gaining electrons, it's going through reduction. And if it's going through reduction, we know it's gaining electrons. So it's becoming bigger. And more negatively charged. And we can see it in the cell, how the electrons are flowing in and they're adding onto the cell. It's becoming bigger. Now, as Cu, or copper, is gaining electrons, we're going to see this in the reaction, in the chemical equation. Now, instead of the electrons being added on the product side, it's being added to the reactant side. Because, again, we're gaining electrons, so it's going to be here. Okay, now let's break it down even further. In CuNO3, we have Cu, which is a cation, and we have NO3-, which is a polyatomic ion, or anion. If we're gaining electrons, that means we're getting less and less of copper. We're getting less and less of the positivity. So not only are we losing positivity, but we're getting an excess of NO3 ions in the solution. So because the positive copper cation is being removed, we're getting an excess of negativity. It's becoming too negative. So that's when the salt bridge comes in and it adds ions to balance it out. The anions, which are negative ions, are going to flow towards the anode, which is here, and the cations are going to move towards the cathode, which is copper. So the reason being is because the cations, which are positive ions, they're going to balance out with the excess negativity that we have here. So it's going to restabilize the amount of negativity with the positivity. And the same thing here. Since in Zn, or zinc, it's becoming too positive, because in zinc, right, we're losing electrons. So to break it down here, right, we have our Zn2 plus, our cation, with our polyatomic anion, NO3 minus. Now, because zinc is the anode and it's losing electrons, this solution is becoming too positive. Therefore, the anions here in the salt bridge are going to come in and they're going to move towards the anode in order to keep the system balanced. And this balance is what's allowing the system and the reaction to continue. So just to summarize, here's what's really happening. We have Zn plus Cu2 plus going to Zn2 plus Cu. So what does this mean? It means that zinc, right, it's becoming a cation. Why? Because if we look first at the activity series, we see that zinc is more active, it's more higher up in the scale than Cu. And the more active metals typically lose electrons more easily. So the first step is that Zn is more reactive. Therefore, it loses electrons. And if it's losing electrons, it's associated with oil. Remember oil rig? Oxidation involves losing electrons. So it's oxidizing. And Zn is an anode. Keep that in mind. So a way that you can remember this is anox, and then red cat. So oxidation happens at the anode and reduction happens at the cathode. Now the second step is that because Zn is losing electrons, Zn is becoming more positive, or it's going to form a cation. Zn forms cation, so it becomes more positive. So now the electrons from the anode, or Zn, is now flowing to copper, which is the cathode. So now Cu, since Cu is less reactive, it's gaining electrons. So it's reducing, oil rig. Reduction involves gaining electrons. So this is a cathode. So because Cu is less reactive, it's going to gain electrons, which is going through reduction, and therefore it's a cathode. So last but not least, we have the salt bridge. And what the salt bridge is going to do is it's going to allow for the flow of ions, anions, and cations into the solution, whether it's zinc or copper, in order to balance the charges. So what's going to happen is that the anion is attracted to the anode. So an anion, which is a negative ion, is going to attract to the anode, which is zinc. So 2Cl minus is going to attract to Zn, which is our anode. And on the other side, the cation is going to be, or the cations are going to be attracted to the cathode. So in this case, 2Na plus is attracted to Cu, copper, which is our cathode. Thanks to the salt bridge, it serves as a way to balance the charges. So because, again, in Zn, it's losing electrons, it's going to need that negativity to bring back the balance because it has an excess of positivity. And in this side, in copper, because it's gaining electrons, it's losing positivity, it has an excess negativity, it's going to need those positive ions to balance it again, to balance the charges. And that is a voltaic cell. I hope this was helpful.